So, another example, and oh shoot, I forgot. I think this might be on page one. No problem. But you're going to scan a little bit further along. Find this image. It says limits review, and what I really like about this is now I have some vertical asymptotes on my graph. And the idea of function approaching an asymptote, as long as you approach it in the same direction, like as long as your result is the same direction from both sides, your vertical asymptote could still have a value that's does not exist. It's either going to be infinity or negative infinity, as long as the behavior matches. And remember, I'm saying it, and maybe I should even like write this down. Remember, a limit, it's the y behavior, and it's near the x value in question, or near the x value you are approaching. Okay, so I'm going to get my vertical bar here because I like that. I think, yeah, that's fine. And maybe we can choose this blue color. Sure, why not? Okay, so there's my long vertical bar to help me block out what might be happening at the point. I want to know what's happening near the point. Okay, so I scaled it down just so I could kind of see both screens. And so, again, feel free to pause the video. If you think you know this and it makes sense and maybe you get the idea and the concept, pause it, do the problems, and then come back to it. Okay, so it says let x approach 13. So I'm going to identify where x is equal to, negative 13. And so then I'm covering this up. So I don't know really what's happening at negative 13. But I do notice there's nothing over here, right? And since this limit value is asking from negative 13 in general, that means I need to know what's happening from the left side, but then I also need to know what's happening from the right side, right? The limit from the left and the right have to match. So from the left, from the right, and unfortunately, I don't know what's happening from the left. So I'm going to say that this limit does not exist because it's an endpoint and because I need to know both sides. Okay. As x approaches 7. So now I'm going to go over to 7, and I'm looking at x is approaching 7, and here's my first opportunity to have a vertical asymptote. And notice that this bar nicely covers that vertical asymptote, right? So from the left, we're just going straight up. And from the right, we're going straight up. So even though it's going straight up to this asymptote, both behaviors, like the behavior of both sides, is going up. So I'm going to say that this limit, although not a number, I can describe the behavior. And that behavior is that they're getting to a positive, really large number, or infinity. Now, a note, this and this does not exist in infinity. Different concepts. Does not exist means the left side doesn't match the right. Does not exist means something's not defined there. Actually, I should even correct myself. It just means the left does not match the right, because x equals 7, nothing's defined at 7, but it's the behavior on both sides. The left side and the right side behave the same way. That's why I can say that's infinity. Okay, now, next one, limit as x approaches 0. So I go to, cover this up. So I go to 0. I noticed that there was a hole. Like there's the limit value. There's the function value down here. Don't care. Look at what's happening to the left and the right. The left side and the right side are converging to that y value that's equal to 10. Okay. Negative 2 just from the plus. Remember, that means from the right. So negative 2 just from the right. So just from the right. As x approaches negative 2, that's the left, sorry. Just from the right. Just from the right is this orange one. From the right means the y values are approaching 10 again. Now from the left, so from the left side, that's this purple one. From the left, the y values are approaching 6. And it doesn't matter that there was a hole there, because remember, we're blocking that out. It's what should have happened. It should be filled in at 6. Okay, now, I'm surprised. An opportune question would have been just approach -2. And notice that 10 and 6 don't match, so that would have been doesn't exist. So perhaps it's further down. We'll see. 14 from just the left. So 14 is an endpoint. It's an open dot, but don't really care about that because I closed, I'm kind of blocking that out with this bar from the left. So we're coming from the left, the y values are approaching -1. And it's just from the left, so I don't have to worry about the other side that's not defined. We get -1. Okay, now, so number 7 says, let's approach 9. So what I'm going to do is I'm going to drag this guy down so I can see it and see my questions. Drag this down. Excellent. Okay, as x approaches 9. So nothing really funny is happening there. It's just the bottom of a quadratically appearing shape. The y values are 0. So if nothing like suspicious happens, if there aren't jumps, if there aren't holes, if there aren't asymptotes, then a limit doesn't really do anything, right? Because the function behaved as it should have. Okay. The limit as x approaches, actually I'm going to save probably 8 for just the end. Let's go to -10. Let's come down to this one right here. X approaches -10. So similar concept. We're approaching the lower part of a quadratic shape. It's an open dot. Doesn't matter because what should have happened is it should have been filled in. The behavior to the left and the right should approach -4. Okay. X approaches 12 from just the left. So x approaching 12 from just the left. Now 12 is our other asymptote, and the behavior on one side of the asymptote does not match the behavior on the other side. So as x approaches 12, I'm only interested from the left. So remember, from the left side, I think it was purple before, but I'll just redraw it. So there's from the left. So from the left, as I approach this, what is the behavior on the left side? Oh, here it is. It's getting higher and higher and higher and higher and higher. So from the left side, the approach of the asymptote is positive infinity. Data does not exist, positive infinity. I'm going to come over here. This one says from the right. So now from the right side, oh yeah, good. From the right. So come back here. So from the right side, they're going really small. And it's becoming negative infinity. I didn't realize I skipped that one, so that's okay. Come back up here. So this is negative infinity. And negative infinity just means you're getting large in the negative direction. That's all. Okay, so then, so I have one side infinity, one side negative infinity, and the last question says, well, what's happening if you approach 12 from both sides? And I love this. I already have it. Purple is way up here. Red is way down here. They're not behaving the same way. One's going to positive, one's going to infinity, negative infinity. This does not exist. This could possibly be the worst splinching ever, which is, in my head, super funny. Okay, now, I want to look at 8, 13, and 14 because now we're going to start transforming the function that you see. And the easiest transformations, I think, are actually 13 and 14 because the transformations happen after the function. So notice that this +4 is outside f of x. That just means that whatever the behavior is the function at 1, you're just going to add 4 to it. Or in this case, whatever the behavior is at -12, you get a result, then you're going to multiply by 2. So those are actually easier because these affect the y value after you've done the limit. So x approaches 1 of the function, x approaches 1 of the function, and 1 is part of this horizontal segment right there, right? So the whole behavior of that is around 10. So I know that this much here is behaving like a 10, then you add 4 to it, so you're going to get a value of 14. And if you link back to what we looked at with transformations in a previous math class, this +4, since it's affecting the y values, all that does is it pushes the graph up 4 units. So the x's aren't changing. I'm still looking at 1, just the whole graph got moved up 4 units. So the 10 moving up 4 units becomes 14. And as I approach -12 and look at that value, so -12, oh, there it is at 0. Oh, that's kind of interesting because, so what's happening is I'm taking that y value of 0 and I'm multiplying it by 2, which is still 0. So, but I want us to realize that that's happening after we've done the limit. So that's 0. And then we take that times 2. So we still get a value of 0. And remember, this is a vertical stretch. So the graph is being stretched by a factor of 2, but it doesn't lose its x-intercepts. And since one of the x-intercepts happened at negative 12, the stretched version will also have an intercept at negative 12. Okay. The tougher one, honestly, though, is 8, because you have to transform the graph, then apply the limit. And so what you want to think about is the graph of x plus 1. The graph of x plus 1, actually what I can do, get rid of that for a second. So and I'm looking near negative 9, which is over here. Okay, so the graph of x plus 1, if I think about what might that look like, I'm going to pick green, go a little bit thinner here. Okay, so here's what f of x is. I'm just retracing it. Right, there's an open dot there. Okay, now what is a graph of f of x plus 1? It means take your image and shift it to the left 1 unit, right? Because remember, plus 1 means you are actually going what would make it equal to 0. So it's a negative 1. So we're going to the left 1. So I'm going to take this and actually shift to the left 1 unit. So I'm going to shift that to the left 1 unit. And when you think about that, now that's where, there it is. So shift to the left 1. So now the green graph is where I want to analyze negative 9. So now negative 9, that should be like right there on the green graph. Remember, it's like the values on this x-axis aren't changing, so kind of ignore the black. So here it was, like there was negative 9. The blue line is on negative 9. I know that because negative 9 exists halfway between negative 10 and negative 8. So you've established where negative 9 was. It's right there. Now move your graph to the left 1. And what is the behavior of the new graph at the blue line? Oh, the behavior is 0. And so one way, if you have a way to easily move the graph, then do that. But here's a better way. Think about x plus 1, where would you have come from to land on negative 9? If I'm shifting everything to the left 1 unit, then want to analyze negative 9, where would you have come from? You would have come from negative 8. You would have come from x equals negative 8. X equals negative 8, shifting to the left 1 gives you negative 9. So rather than focusing on the end result, focus on where would you have started. The graph that I have, I would have started at negative 8. And what's the behavior of negative 8? Oh, it's 0. So that's another way to do this transformation. And in fact, this value of x plus 1, you could directly apply it when it's inside the function like that. You can directly apply this transformation to this. In other words, negative 9 plus 1, that's negative 8. So this is equivalent to saying the limit as x approaches negative 8 of the function that I see, because negative 9 to get there would have come from negative 8 after I shifted it to the left 1 unit. And so that's a tougher concept, and you're going to play around with that for a little bit and struggle with that for a little bit, and that's okay. But I wanted to stress that, and I want you to try a few examples. Okay, so I'm going to stop this video. Then I want to do a video going through our calculator table feature as well, just to give us another intuitive understanding of limits.